Hello class, welcome for your very first video of your Math 8 Algebra Flipping the Classroom. And we're going to start with Chapter 1, Algebra, and Section A, Algebraic Notation. This may be a review for some of you guys, so we're going to go through this video a little bit quicker than what we normally may have. All right, in each video, we will have objectives that we are trying to accomplish. So at the end of the video, you should say, do I know anything about these objectives? Because this is what we're hopefully trying to learn. This video, depending on how long it takes, it may be split up into a couple of different videos because I want to keep them short in the beginning and I want to go through these in class. So I just want to make sure that these videos are not too long. So our objectives for this section are to simplify algebraic expressions using index or product notation, to translate between words in algebra, whether you're given an equation or an expression and you have to rewrite it in words, or you're giving a word problem and you're rewriting it as an expression. And then we're going to write algebraic equations. All right, so that is our objectives, what we want to be able to do by the end of Section A. All right, so let's go ahead and move on to the key terms of this section. All right, so the key terms that you will have to know is one, a variable. And a variable is a letter or a symbol used to represent a value that can change. So your variables can change as well. You can have X, Y, Z. You can have any variable that you want to use, you can. In most problems, though, you do have to go ahead and define what your variable is. But a variable is a letter or symbol that represents a value that can change. All right, a constant is a value that does not change, and a constant is going to be our numbers. So if I were to write 4x, in this case, our variable is our x because that can change. I can substitute whatever value I want to in for the x, but the 4 remains the same. We will always be multiplying it by 4. Right? So that 4 does not change, so it is a constant. The next thing that we will discuss is a numerical expression. So it's important that you understand what an expression is. An expression is a group of terms that does not have an equal sign, but a numerical expression only contains constants and operations. So 4 plus 5, both of these are constants. 4 and 5 are 4 and 5. They cannot change. They can change when we add them together, but that's different. All right, but 4 and 5 are constants, and it's being added together with a plus sign. And then the last one is an algebraic expression. So an algebraic expression may contain variables, constants, and operations. It contains them all. But once again, the main thing is it does not have an equal sign. So 4x plus y. This is an algebraic expression because we have constants, variables, and it's being added together. So we have an operation. If I were to say 4x plus y is equal to 5, this is no longer an algebraic expression because we have the equal sign. All right, so make sure you guys write down these definitions and that you understand these. So let's go ahead and move on to solving some problems that you will need to cover in this section. All right, so the first thing that we're going to cover is product notation. All right, and what product notation means is you might be given a problem that is written out in a way that is as difficult for you to read, but also for you to use if you were to try to solve some problems. For instance, if I said 3 plus 3 plus 3 plus 3. You don't want to write 3 plus 3 plus 3 plus 3 every time. You want to try and rewrite this in a more simpler way. So what we can do then is whenever we're adding the same number together, so whenever we're adding 3 together, however many times we're adding it together, we can simply just multiply it. So we have 1, 2, 3, 4, 3. So we can rewrite 3 plus 3 plus 3 plus 3 as 4 times 3. And we do this by using the product notation where we are multiplying them together. So it allows us to rewrite something that may be long-winded and difficult to say to something that's easier to say, and also it'll allow for us to solve our problems a little bit easier when we go ahead and start dealing with the equations. So let's just go ahead and solve a couple of using product notation. All right, just for interest of time, I may not always go through every example that's here because I'm screenshotting these from your book, so maybe I'll only go through 1 or 2 of them. All right, but we're trying to simplify these and rewrite it using product notation. So here, C plus C plus C minus D times 7. That's a lot to say, and if we were to try and use this in any other problem or to keep going with this, it'll be difficult for us to add or subtract or to solve. So what we need to do is we need to rewrite this. So remember, whenever we're adding the same value together, we can rewrite it as multiplication. So I have C being added together 3 times. So I can rewrite it as 3 times C. Now it's minus D times 7. So I can go ahead, because of our PEMDAS, I can multiply D and 7 together and get 7D, and then I can go ahead and subtract them. All right, so this C plus C plus C minus D times 7 can be rewritten as 3 minus 7D. All right, I'm going to go ahead and skip the second one, and I'm going to move on to the last one. And this one is 4 times x plus y. See how this x plus y is in parentheses? That means the 4 needs to be distributed to both. So I can rewrite this as 4 times x, or 4x, plus 4 times y, or 4y. All right, so it just allows for us to rewrite this in a more simpler form for us to not only read, but to use later on. All right, the last form that we did was product notation, which product means multiplying together. Here we have index notation, and index notation is going to be where we have something raised to a power. So this is written in index form because we have a power. So whenever we see index notation, that means that we are going to be rewriting something raised to a power. So before, if we did x plus x plus x, this was equal to 3x because we have 3 x's being added together. There's a difference when we do x times x times x. When we're multiplying all 3 of these, we no longer do 3x, we do x to the 3rd power. Because remember, whenever we have something raised to a power, it is telling us how many times we're multiplying that thing together. So this x to the 3rd power, if we were to expand this out, is telling us we're multiplying x together 3 times. So since these are being multiplied together 3 times, we cannot write 3x, but have to x to the 3rd power. All right, let's go ahead and do a couple problems with this. All right, so for these, we want to simplify using index notation. So for here, I have P times P times P times P times 3. That's annoying to say. And it's annoying to actually look at when you look at it like that too. We always want to simplify. Everything in math always gets simplified. You never leave it unsimplified, right? Always simplify. So since we are multiplying P together 4 times, I can just simply rewrite this as P to the power 4. That is my index notation. And then it's being multiplied by this 3, so it'll be 3 times P to the power 4. All right, the next one here, we have all of these are being multiplied together. Since it's being separated by this plus sign, we need to go ahead and look at these differently. All right, these are 2 sets that we're looking at essentially. So the first one, we have z times z times z times y. So that means I have z raised to the 3rd power. So it'll be 5y z to the 3rd power. Whenever you're writing these, you always want to try and rewrite this in alphabetical order in each term. So since y comes before z in the alphabet, I wrote y first, right? And then we will add, and then we do y times y, and that is y squared. All right, so this gets simplified to 5y times z cubed plus y squared. All right, the next thing that we're going to go through is algebraic expressions. And this algebraic expression we already discussed. It is a form that contains numbers, variables, and operations and signs. So we're going to now take words and rewrite it as algebraic expressions, or vice versa, where we will take an algebraic expression and rewrite it into words. All right, so we're going to actually do that one first. I'm going to give you an algebraic expression, something like this, 2x plus 3, and you will have to rewrite it in words for me. Right? It is vital that you can translate an equation or an expression into words and vice versa, right? Because a lot of times in real life math, it's not going to be given to you like it is in a book where it will say 2x plus 3. You will be given these unknowns and you will have to kind of identify how I can rewrite this in order for me to solve. All right? So it's vital for you to be able to translate between words and math. All right? Math is a language. It is a language, and being able to translate from one language to the other into words is vital, is important. All right, let's just go through a few key terms first. All right, when you are going to rewrite these from words and vice versa, you need to know how we talk about each operation. So the plus sign, we simply just say plus, sum, or increase by. All right, so that allows for us to go ahead and describe. I'm going to talk about these words together at the end. All right, but for the plus sign, you simply just say plus, sum, or increase by. For the subtraction sign, you can say minus, you can say difference, or you can say less than. So anytime you see these three words, or four words if you include less than, you know that you're talking about subtracting. Right? So then for multiplication, we can say times, product, or equal groups of. This one you probably won't really see it much, but it's another way that you can describe it. And then the last one is the division sign. And division is simple, divided by or quotient. All right, so now let me talk about these four words I highlighted in yellow. All right, so for these four words, order matters, all right? And so does less than, but these all four have the same order. So what I mean by whenever we're using sum, so if I'm saying x plus 7, and I say the sum of, I always start with the first letter or the first term. So this will be the sum of x plus 7. All right, so for difference, same thing. Whenever I'm talking about the difference, if I'm saying x minus 7, the difference, I have to read it as the difference of x minus 7. So it always starts, whatever I say first is the first thing written, the difference of x minus 7. The difference of 7 minus x is not the same as x minus 7. For product, if I say 7x, this one I will have to say the product of 7 times x, or the product of 7 and x. All right, so whenever we're using these four words, whatever we say first goes first. And then the last one, if I say the quotient of 7 and x, that is meaning 7 divided by x. All right, so order matters for these. Order matters. All right, so let's go ahead. We're going to do a couple problems with these, and then we'll move on. I know this video is a little bit long already, but we're almost done it. All right, so here it says, give 2 ways to write each algebra expression in words. So if we're doing this in words, I can simply just say 9 plus r. Right, that was one of the ways that we can describe the addition sign. We can say plus, we can say sum. So just remember though, if we say the sum, so the sum of, once we use some different quotient or product, we have to go in the same order as presented to us. So it will be the sum of 9 and r. If you said r and 9 for addition, you're technically not wrong, but it may trip you up for every other one that we need to do. Right? Now for here, we can then say q minus 3. Right? You can keep it very easy if you want to, but sometimes your book will not be that easy. Most of the ones that you will see, I feel like, is the one here I'm about to write. We also can describe the minus sign as difference or less than. So we can say the difference. Just remember, whenever we're saying the difference, we have to go in the correct order. So the difference of q and 3. So since I use difference, I have to go in the exact same order that it's written. Right, just to go over less than, because that was in the other, and as another one that we can use for minus. When we use less than, though, it's actually opposite of difference. So here we will say 3 less than q. So if we wanted to actually use less than, we have to go in reverse. Right, the way that you can maybe think about this is D is in the beginning of the alphabet, so that means we need to start with the beginning of our expression. L is kind of at the end of the alphabet or in the middle, so that means we need to start with the reverse or the back part of our expression. You can kind of think about it that way. All right, then I added this one here just because I wanted to add product, and this is our last problem we're doing. We're already reaching a pretty long time for this video, so I just wanted to combine some of them. So for this one, once you see it's broken up by this plus sign, that means that you should go ahead and describe these two together, or this one first, the 3x squared first, and then we can then combine the adding it with the 7. And you can do it any way you want. You can say plus, you can say sum. So I'm going to use the sum, right? So first I'm going to say the sum of. So now that I established a sum of, remember, when we use sum, we have to talk about them in order. So that means I need to talk about this 3x squared first. So now in order for me to talk about this 3x squared, I need to say, well, what's going on here? So it's a sum of, and then I can say 3 times the square of x, or x squared, and 7. All right, and we can describe this any way. We can say the sum of the product of 3 and x squared and 7. We can say the sum of 3 times x squared and 7. We can describe this in any ways. Just remember, once you see that it's separated by a plus or a minus, you should really focus on how do I then talk about each term by itself. All right, that is it for this video. We will finish this section with the next video that we move on. All right.